So we've got our truss, we've got our sidebars, we've got our columns. We've got the basic geometry in there, but we haven't really addressed cleaning up any of the intersections or where these structural members meet. So the next couple of steps, we're going to go through and do some cleanup work. There's a couple of different tools that we can use for that. And well, actually, first of all, let's go ahead and turn off the display of axes. We don't need those red lines. And we can see the top two beams of the truss don't quite meet. So this is actually a very easy cleanup that we can do. We can select both of those beams, and with the quad under model, there's an LConnect. Now, once I click LConnect, at the bottom of your screen, just above the command prompt, you'll see what we call is the hotkey assistant, or the HKA. This will give us additional options within this particular command. The way that it works is when you hover over the little I for information, it tells you what's possible. We can press the control key to toggle to the different options. And the different options are a mitered connection, a first solid, second solid, disconnect. So those are my options. It's a little confusing because I can't use my mouse to click on those, but I can use either my control key, or if we read at our command line, we can click switch or type S. So when I do that, any one of those three, you'll see my graphics change to go through these different connections. So is the L connection, the miter connection, things like that. We actually want that first, that mitered connection is what we want, so we can go ahead and accept that. So we've got that. Now, of course, it'd be very quick to go ahead and do that for all of our top beam connections, but we have an easier way to do that. And again, that answer is propagate. So we'll launch propagate. And this time our two reference solids are those two beams. But this time we don't have any detail options. So we can just, remember that's an optional. So we can just hit enter. It will zoom in and show us that area to be copied, which is fine. So we'll hit enter again. And then BricsCAD will analyze where those connections could be cleaned up. And again, we're just going to hit enter to take those. So now, again, very quickly, we can see that those top beam connections have been cleaned up for us. Again, very quick, very easy to do. So that's one cleanup. But we also have some cleanup to do where all of the truss members meet the column. So we can see how they haven't cleaned up. And that's what we'll do next. So we'll select the column, the bottom beam of the truss and one of the truss members. And similar to LConnect is structural connect. And this is used to clean up structural members. Generally think of it as, you know, an LConnect will do two members. Structural connect is more than two. And again, let's see, let's try that again. Did I get rid of my lines? I did get rid of my lines. There we go. So that cleaned that up, the connections of those three, but we still have this top beam and column to clean up. So again, that's two connections. So we can again go into the LConnect. Again, we have the hotkey assistant. This time we'll hit control or switch twice because we want, let's see, we can toggle through these and see what we want. I think that's what we want there, and go ahead and accept that. So that's looking better. And we can also propagate this. So we'll take those four as our reference solids. Again, there's no detail, so we'll just hit enter again. This takes a little bit longer, again, and we'll go ahead and take all the suggestions so that that cleanup detail is applied to all of the ends on both sides of my grid. and we can see how that's done for us. Again, really quick, really easy to do, but what's really important, especially when we're working with a BIM model, is that we're able to raise the level of detail across the model. So we're not just modeling one section of our entire model, but we can apply this so that anywhere you look on our structural grid is correct and has been cleaned up. Okay. We're going to go back to the details panel that Ken introduced. And again, here we can manage our libraries and go in to see where we're saving that information. Again, there was a detailed structural folder in part of the handout or the files that you downloaded. So you just want to make sure that those are available for you to see. And what you should see is a, let's see, I prefer the list view, is a folder called structural. And there's a detail in there called truss connection. Now, let's see. Yeah, okay. So as Ken has already showed us, once we have a detail in our library, we can just drag and drop it, and it will propagate it throughout our model. So first of all, let's take a look at what this detail looks like. And we can see that really what this is, it's the connection of the individual interior truss members to the top beam, right? So that's what it is. And that's really all of these connections. So let's go ahead and propagate with that. And this is going to take a little bit longer because, as you can imagine, there's quite a few connections here. So it's analyzing the entire model and determining where that truss connection detail could be applied. You've seen now that we've used propagate several times in different ways. So this is just one other way that you can save a detail and then simply drag and drop it into your model. And again, as Ken mentioned, this is a great way to share and reuse details on a project or even within your office. Sometimes you have standard office details that everyone might be able to use, and that's a great way to use that. So here again, we have all of the green check marks. We could go in and turn some of these on or off. We're going to just take everything. And notice that even though our detail showed us the connection of the members to the top beam, it's also applying these to the bottom beam because it's basically the same type of connection. So it actually created 136 different connections for us. Again, to do all of that manually would be very, very, very time consuming. And now we can see how everything has been nicely cleaned up in about a minute, maybe two. So that's great work. Okay, so now we've got most of our geometry in here. We've cleaned up a lot of the connection to the connections of all the steel. But there's one more detail that we want to work on, and that is where the column and the beam meet. We probably need some kind of bolted plate connection to support that. Now, I do want to emphasize that BricsCAD BIM is not a structural detailing or calculation software. However, if it's been designed, you know what structural components are needed, what connection is needed, we do have the ability to model that information here in BricsCAD BIM. So that's what we're going to do. We're going to create a bolted plate connection. Now with that, some of what we will use is going to be in the mechanical parts library. So first of all, let's isolate the column and the beam because that's really what we're working with. and also on the library panel. So let's go to our library panel. We can see here that I have different libraries. We have a Brixis BIM library and we have a Brixis mechanical library. You want to be sure that the mechanical library is turned on because we are going to actually use some bolts that are part of the standard parts in the mechanical library to create our bolted plate connection. Okay, so to start with, we need a couple of plates. So to create a plate, we're just going to draw a box. So just draw a box. And remember, make sure that your dynamic UCS, DUCS is turned on, because as I move my cursor, you see how things turn a light blue. That means my dynamic UCS is working. So we want to hit the shift key so we lock in that dynamic UCS so we can draw this plate from the upper outside edge of the column to that inside bottom edge and give it a thickness of 10 millimeters. So there's our first plate. Now, the plate, though, needs to extend on both sides of the beam. So we can use push-pull here. And I know I'm hitting my control key to toggle from my solid to the face. I can also just turn on prioritize selection of faces so that I automatically get that face. And then we can push-pull this a distance of 20 millimeters on each side. So there's our plate. Now I've been told that I need 6 bolts. I need 3 bolts on each side of the plate. So in our library, we can go to standard parts, to fasteners, to bolts, to hex head bolts, to ISO hex head bolts, and we want to use the ISO 4015 bolt. So to begin with, I'll just drag and drop 1 bolt here. And notice again how the dynamic UCS is snapping into the face of that plate. And again, notice I have my dynamic dimensions, those 2 boxes of numbers. That is going to allow me to very accurately place this bolt from the side edge and the top edge of the plate. So I want to be 30 millimeters from the side and hit tab so I can type in 55 millimeters from the top. And now we have our bolt, but I need 6 bolts. So again, I could use copy, I could do an array, but we're going to use propagate. And to use propagate, again, our plate is going to be the reference and my bolt is my detail that will be copied. We'll hit yes, because this is the area that I'm working with. Now at this point, you may need to zoom out a little bit because we get this question mark. The question mark basically says you've got some options to be made. And when you click it, we can see that we've got another couple of options. I want to go with a grid. I know I need a grid. It put 4 in there for me, but I need to add a row because I know that I need 3 on each side. So we'll just click add a row. Now I have 6 bolts. We can apply that. And there we are. So we've got our plate, we've got our bolts, but probably I've been told we need a little bit more because we probably also need a plate that would be welded here during construction so the beam can be placed. So how are we going to draw that plate down there? Well, we can do a couple of ways. We can extrude the bottom face here. We can use our extrude. So that comes down a distance of 15 millimeters because that creates a new solid. And then we can use the push-pull to extend this out an additional 40 millimeters. So eventually this would be welded. We're not showing that. We're just showing the solids here. But now we have a place for that for that beam to rest. So we've got our plate, we've got our plates, we've got our bolts, but they're just solids. So because we're working in BIM, we want to classify them. So let's see, we can highlight both of the plates and classify them as plates. Again, going into BIM and that manually or classify manually, and just type in plate. Now we can see that when I hover, we can see it's been classified as a plate. Both of them have been classified as a plate. The bolts we can select, make sure you select all 6, and classify them as mechanical fasteners. Now they're classified as mechanical fasteners. Now, the last thing that we want to do is to classify the entire bolted plate, bolts and plates as a building element, so it will be one block. So again, we'll select the bolts, 6 bolts and 2 plates. Go back into classify, and this time we want them to be building elements. So they're core building elements, and we want to click here to convert to a block and classify the block reference. So we do need to give it a name. And I'm going to call it bolted plate block. Now, and hit enter. So now we can see that this is a building element. It all highlights together, and it's called a JK bolted plate block. Now, at this point, you might want to do a file save as. So you save this because you would need to close BricsCAD in order to see that new detail. So if I go, but I just happen to have done this a couple of times. So let me just show you populating that detail, and then we'll take a break. So let's see here. So we can now save, now that we've got this, I'm sorry, I'm a step ahead of myself. We're going to save this as a detail. So again, in the details panel, we can create the detail. We can give it a name. I'm going to call it BC bolted plate Tuesday, because I have several of these. And again, we can just keep it in our current category. And again, as Ken has explained, we need to pick the reference solids, which is going to be the beam and the column, and our detail, which is our block. We don't need to create a section, and we'll go ahead and create that. And we'll accept it. And again, you could click on the little pencil to change the view. You can add tags. I'm just going to hit save. And there you have it. And then we show everything here. Oh, see, it did show up. Okay, this one did show up. Excellent. I think Melissa was correct. If you don't go in and edit it, it will show up immediately on your detail library, so we don't have to exit and save. And now we can just drag and drop, whoops, drag and drop that right in. And we can see all of our check marks. Now the question mark is saying, hey, what do you want to do here? Because this is what we use to generate our detail. So we do want to go ahead and click that so it becomes a check mark, and then the detail will be replaced from the library into the model. And we can see that now that's been applied to all 16 sections. Except I've got it upside down. Okay, I did something incorrectly there. But anyways, let's stop there. And again, at this point, you might want to save your drawing if you've gotten to this point, because we'll do some back and forth when we come back. So let's go to the breakout sessions and go from there. So any questions coming out of that? There's a lot of information there, I know. One thing that I would recommend, if you are having any trouble going through this, when you go through it, save your file at multiple points. So if you have to go back, you don't have to go back and do everything. So to wrap up today, I just want to talk a little bit more about taking these details even a little bit further. I'm actually going to start with something a little bit later on. And what we can also do is, we've been working with blocks. We can also, because of the BIM license, share some functionality with some of the mechanical tools. We can create components which are like a block but have more capabilities to them. As far as if we look here, this is a component. I've skipped ahead in the instructions. It goes through basically taking that block, that plate, the bolted plate block, and going back and making it a component. And the reason that we would make it a component is that gives us some options where we can open a copy of this component. And you can see, let me turn these on, that we have this BC subtract layer. This BC subtract layer is special because within components, we can have features. And a feature would be something that adds geometry or removes geometry. So in a component, we can use that removal of geometry to, in this case, create holes where the bolts would go into. Because if we really wanted a very truly detailed model, we would see the holes where those bolts go in. So the instructions take you through creating, basically exploding that bolt that we created, or I'm sorry, the bolted plate that we created, and creating a component, which you have to get all the bolts in there, which is BM form, which allows you to create that component. Now, before I do that though, we do need to, let's isolate this. There are some steps in there to, actually you'd also need to change your UCS so to the face of this column. So you want the Y going up, and that is important when you're creating components because you want them to be inserted in the appropriate place so that they're laying flat on the surface here. And then when we create that component, it's called BM form. We create a local component using the back midpoint of the plate as our component. And we need to give it a name here. And we'll call it bolted plate component 2. And there's a couple of other steps here that go in and classify this. But basically what I want to do is just kind of show you the end result. So we looked at the copy of that bolted plate as a component. Now I've gone ahead and I've propagated that because we save the steps, have you go in and save it as a detail. And we can see that here's the bolted plate component. If we open it up, we can see that that's what it looks like. A component works in many ways just like a block in regards to the detail library. So you can save a component as quote a detail, And then you can drag and drop that component into your model and replace it. So now we can go in and we can hide the plate and we can see where those bolts are. So it's a couple of steps in there.